Hello everyone. Welcome to our session, AI Pioneers, Shipping Transformative GenAI Architectures in Production. I am Pranav Sharma. I am EMEA Lead SA for AWS SMB Business. And I'm joined by Jay, who is Principal Solution Architect, again supporting AWS SMB Business. And we have our customer Safwan, CEO of Misraj AI. Let's get started. So agenda for our session is, we'll begin with providing a quick overview about AI Pioneers, who they are, how do we identify them, and the kinds of architectures that they build. We will then dive deep into 3 AI Pioneer architectures and use cases that we have seen our customer build this year, right? The first one, we will be talking about building LLM serving platforms. Now, over last 2-3 years, LLM inference has become one of the most widely adopted workload across the industry. So here we will present to you a few architecture patterns that you can use to scale LLM inference within your own organization. Next, Jay will come up on stage and talk about creative content generation. Now, AI's ability to generate images, videos, short-form videos is at the heart of transformation that we are seeing in industries like marketing, media and entertainment, and others. Here, we will present to you an architecture using which you can fine-tune an image generation model using images from your own organization to tailor it to your specific use case. And then we will have Safwan come up on stage and present the story of Misraj AI, who have built a pioneer Arabic vision language model for document processing use case. And we'll wrap up the session by talking about an emerging architecture pattern that we see our customers gradually build as we move on to 2026. So let me begin with talking about AI Pioneers, who they are. So AI Pioneers are the organizations that are using AI to build transformative customer-facing architectures and use cases. These are often small teams, very agile, but with very big ambitions. And they're often trying to disrupt the industry where they're at. Now, the common architectures that we have seen them build, right? They are not your usual consumers of AI over APIs, right? These are the organizations which sit and develop much closer to the AI infrastructure itself. So typical profile would be, they would be either model builders, customizers of the models, or they might be running LLM inference or any other inference of foundation models at scale. Now, let's talk about our first AI Pioneer use case, that is building LLM serving platforms. So what are LLM serving platforms, right? As I mentioned, over last 2-3 years, LLM inference has got widely adopted across the industry. Now, what has emerged is that we have seen LLM inference have now become one of the foundational building block of the modern architecture. Much like compute, storage, networking, we now have LLM serving as one of the other foundation block of the modern application. But scaling LLM inference is actually quite complex due to a number of reasons. The first one is the sheer model size, right? Now, some of these models are actually, you can't even fit them not just in one GPU, but you actually need multiple GPUs, multiple nodes to serve them, right? So that makes it complex. The other reason why these are complex is also they have these thinking budgets, right? So you may have seen that reasoning models, you assign these thinking budgets to reasoning model, and then they consume that during the runtime and then produce a response for that, which is unlike any other workload we have seen. And there are other reasons as well. Like for example, the request response to an LLM is quite varied. It could just be like one word, one line, 10 sentences, maybe tens of pages. And the outcome is also quite varied, right? It could be just, again, same, one word or tens of pages. So again, very different from the classic workloads that we are used to scaling like microservices and others. Now this makes LLM inference famously called as an extreme engineering problem. Now, organizations, rather than trying to at application level solve LLM inference, what they are now gradually doing is they are building these centralized LLM serving platforms, through which what they are doing is they are bringing in all the engineering capability within this centralized team and making it easy for the application teams, right? So that they don't have this engineering overload. And by that, they are able to improve governance and also increase the rate of delivery very, very fast. Now let's talk about what are the common requirements of an LLM serving platform, right? Now let's begin with thinking about a mid-sized organization, right? What they want to do is they want to serve their customer very quickly with a number of generative AI features. The first thing then they need is good model choice. They want fast access to foundation model very quickly without worrying about, how do I scale this, etc. So they want to do it fast, quick, but then they want access to foundation models and also innovation in the open source community. So the first requirement is model choice. As they start building generative AI applications, the second requirement of an LLM serving platform is supporting services, right? You would need vector databases, different guardrails, security, observability, and other requirements as well to build generative AI applications. So the second requirement for a LLM serving platform is supporting services. Now let's think about a startup, right? They want to offer LLM capabilities as a service to their end customers, right? So for them, SaaS-like capabilities are very important. So they care about rate limiting, cost attribution, usage reporting, and other features. Now let's think about an AI pioneer organization, right? They want to build their models, deploy their models, and run them at scale on an infrastructure that they manage, right? So that they can fine-tune it, optimize it to serve the needs of their user. So they care about access to accelerated computing instances, fast networking, fast storage, very different requirements. So the fourth requirement of an LLM serving platform is ability to host self-managed models. And finally, the fifth requirement, let's think about these large enterprises or banks. So while they use and deploy LLMs on cloud, but they also have requirements to deploy them on-prem, right? For a variety of reasons. It could be regulation, or if they want to, have their applications and LLM inference sit side by side due to latency constructs as well. So the fifth and the final requirement of an LLM serving platform is ability to host models anywhere. Now let's see how we are going to build that. Now gradually what we are going to do over next few slides, right, is build a singular architecture which will solve all these 5 requirements that you have on screen. We'll begin with a very simple architecture, that is a managed architecture, which will meet the first 2 requirements, that is model choice and supporting services. Then we will gradually add the SaaS capabilities on top of it and come to the SaaS architecture pattern. And then we will further elaborate it to include self-managed models capability of your own infrastructure through the hybrid architecture pattern. And finally, we will add the capability to bring your own infrastructure, that is deployment on-prem and other places as well. So we will iteratively build them over next few slides. Let's get started. So the first is the managed architecture, and we will be talking about the top 2 requirements that we discussed, that is model choice and supporting services. Now this is the simplest one, right? You have generative AI application, you can talk straight to Amazon Bedrock, which provides model choice and also supporting services as well. Now it's super simple to get started, but it can scale also to the extent that you need to serve your customer, right? The simplicity of this architecture is critical. Now let's take a quick example, right? Imagine you're building a retail shopping assistant, right? So the first thing you need is access to a foundation model because you are building something customer facing. So using Amazon Bedrock, you can very quickly get access to frontier AI models like Anthropic Claude Sonnet 4.5, etc. Now you may have a number of product specification documents, etc. that as your customers talk to your retail shopping assistant, you would want to use information from those documents to provide response to your customers. Now you can do this using Bedrock knowledge bases, right? You can ingest all these documents, knowledge bases will vectorize it, and your generative AI applications can start querying over these knowledge bases. The next capability often you would need as your users start talking to this retail assistant is some kind of safeguarding capability, right? Because you would want to identify and redact PIIs. You want to ensure that there is no toxic content, so you want to quickly identify that. And you also want to ensure that the model is not answering through its own knowledge, but using the documents that you have uploaded in the knowledge base, right? So that's called contextual grounding. All of these features are available through Bedrock guardrails. With very simple configurations over APIs, you can very easily build this capability into your GenAI applications. Now, as your assistant gets popular, you will want to analyze over a period of time what are the types of queries my customers are asking this assistant to further improve it, right? So you want access to chat logs, the number of sessions that might have had, because your business might want to get some reporting on top of that. And all of that you can do through the session management capability of a Bedrock knowledge base. And then finally, you have awesome prompt management capabilities as well baked into Bedrock, wherein you can version control your prompts, reuse your prompts so that you don't start from scratch when you are building next set of applications. With this, I hope you get a sense that this might be one of the simplest architecture somebody can show you, but you can see the power of it, that how quickly you can start and scale to support your customers. Now let's move on to next one, right? Here now let's add SaaS capabilities, right, to the architecture that we have already built. Now if you pay attention here, we have introduced one block, that is the LLM gateway block between your generative AI applications and Amazon Bedrock from the previous architecture that I presented. Now this particular LLM gateway block will introduce the capabilities, SaaS-like capabilities, right? Again, let's take a look at this with an example. I'm sure all of you and in your organization, you are using agentic coding assistant, right? They are the story of 2026. Now imagine you are a team of say 30, 40, 50 developers and you want to use agentic coding assistant, but you can't agree on one, right? Many of them have their own preferences and want to use their own tool of choice. Now, how do you support that in a right way within your organization? So you can use this architecture that I'm showing you here. So imagine the generative AI applications shown there are different agentic coding assistants, say for example, Claude Code, Klein, Roo Code, or for example, even codecs from OpenAI, right? You have diverse of these applications. They all connect to LLM Gateway, and LLM Gateway then forwards the request based on the need of the application, either to Bedrock or to any other provider like OpenAI in this case. Now this LLM gateway, one of the first requirements that you will have is, I don't want one or few developers to consume all the tokens that I might have provisioned for my entire organization, right? So you want some kind of rate limiting capability. That you can define using this LLM gateway, so that at per developer level or at team level, you can create boundaries of rates. You can add further governance and control capabilities like cost attribution, usage reporting, chat logs, etc. Using LLM gateway very, very easily. And LLM gateway also brings in resilience capability. Now, how that happens? So for example, if you have been using Bedrock, you know that you provision quotas for these large foundation model. Now, using LLM gateway, you can also load balance it across multiple AWS accounts. So Bedrock sitting in multiple AWS accounts, you can load balance across that. So if you get token consumed from one account, it can start pointing out to other accounts. So this way, even the resilience capability gets added. Now let's dive deep into that particular LLM gateway block to quickly look at what is under the hood in that block. As you can see, this is an containerized application hosted on Amazon EKS, but you can also host it on ECS if that's what you like. Now this application is packaged up around the Light LLM open source solution, which brings it all these number of the SaaS-like capabilities like rate limiting, usage reporting, etc. that we discussed. Your generative AI applications will be given a simple CloudFront URL to which it will connect. And then CloudFront, as you start connecting with that, it will route the request to application load balancer, which in turn will forward the request to the container or the pod running on EKS, which then, as required by the application, will route it to underlying provider, either Amazon Bedrock, or if it is OpenAI, to OpenAI or any other provider that you might wish. So as you can see, this is doing all the transformation under the hood, and this particular architecture actually is also very helpful if you are doing migrations. So imagine if you built some application on top of OpenAI or any other provider, and you want to bring it to Bedrock without making any change, you can just put LLM gateway in front, and without much changes into your application, you can start using Amazon Bedrock. With this, I hope you understand we have now built SaaS-like capability on top of our architecture. Now let's move on. Here we provide a ready-to-use solution. You can just download this LLM gateway and set it up on your AWS account and get started today. Now let's talk about the self-managed infrastructure, right? That is the fourth capability that we want to add to support the AI pioneer organization. Now here, this particular capability will be supported by Amazon SageMaker HyperPod. This is the service that we will be using to support AI pioneer organizations and their requirement. Now, this AI pioneer organization has built a new foundation model, right? It is an awesome foundation model, quite big in size. So one of the first requirement this organization will have is access to accelerated computing instances, right? Some of the latest. So they might want access to latest NVIDIA chips or custom silicon innovation from AWS, or they might want to use AMD as well, right? All these different accelerated computing instances are available through SageMaker HyperPod. Using flexible training plans, you can get very quick access to these accelerated computing instances. Now, since this model size is huge, right, you can imagine that maybe it doesn't fit into one particular instance or a node. So you need multiple nodes to deploy like one instance of this particular model, right? So one of the requirements the organization will have is how can I have these nodes in close proximity to each other, right? So that the time is not wasted in like when the nodes communicate with each other. And that is the requirement that SageMaker Hyperpod fills out of box. So when SageMaker Hyperpod provisions these accelerated computing nodes, it provisions them over a single spine, right? So that there is very low latency between them as they communicate. Now, once the nodes are over a single spine, the next requirement they will have is how can I have super fast networking between the two? And that comes through pre-configured Elastic Fabric adapter, right? Elastic Fabric adapter provides super fast network connectivity between nodes, even including OS bypass itself, which is required for LLM inference and training workloads. Now, as they scale this particular LLM model in production, one of the requirements they will have is how do I measure metrics like time to first token, time between token, and other LLM inference specific metrics. Now, they don't have to build anything, right? It is available through one-click observability solution which comes with SageMaker Hyperpod, right? You just click a button, and through that, you start getting inference-specific metrics in there, and I'll show you a bit more detail in next slide. And then as you scale in production, things will go wrong. One of the nodes will fail or some other issues will come. SageMaker Hyperpod comes with a number of resilience features, and one of the most important one is this whole automatic repair capability. What happens with this is basically through pre-configured health checks, the nodes are always analyzed, and as soon as a node faces some challenges, it is replaced automatically by the service, thereby reducing the impact on the LLM model that you might be serving. Now, let's zoom in into this particular block and take a look what is under the hood. Now, as you can see, SageMaker Hyperpod is being orchestrated by Amazon EKS here, right? So all the nodes that I described that will be provisioned by SageMaker Hyperpod, those will appear to you like any other node in your EKS cluster, right? The deployment experience, working with it experience is going to be same. So how do you deploy models now on SageMaker Hyperpod provisioned nodes, right? You can use models from S3, you can deploy models from Amazon FSx for Lustre, or you can also deploy from SageMaker Jumpstart, which is our one-click deployment solution or model hub available. Now, within your organization, we also appreciate you may have a number of different personas, right? So there'll be developers, there'll be MLOps people, there'll be data scientists. And all of them will have very different tooling expectations, right? So for administrators who are comfortable by using Kubernetes, they can use kubectl to do the model deployment and governance. The data scientists which are comfortable using the notebooks, they can use Python SDK and then interact with the SageMaker Hyperpod cluster without knowing anything about EKS, etc. And then we also provide Hyperpod CLI, which makes it super easy to manage and deploy models on this particular cluster. As you can see, it very easily has integrated into the rest of the stack that we presented. So iteratively, we are able to include the managed model capability here as well. Below, you can see the one-click observability solution that I talked about, right? That is provided by Amazon CloudWatch, Prometheus, and Grafana, right? Together, they bake in this capability of one-click observability solution. Now, let's move on. Here again, we have this QR code which you can scan. It provides a lot of good guidance on AI inference running on Amazon EKS, and it will help you get started very quickly. Now, let's move on to the final architecture that we want to add to our overall architecture. That is capability to host models anywhere. That is ability to host models on-prem, yet it seamlessly integrates into this architecture that we are building, meeting the requirements for large enterprises and banks, etc. Now, this particular capability is provided through EKS hybrid nodes, right? EKS hybrid nodes is a capability where we give you a deployable package which you can set up on any commodity hardware or any virtual machine on your on-prem estate, right? And we do provide a CLI, that is Node ADM CLI, through which you can achieve the configuration of these nodes. And once you set it up properly, and then there is a connectivity between your on-prem and cloud, these nodes that are provisioned on your on-prem estate appear in your EKS cluster like any other node that you might have on cloud, right? And your deployment your deployment experience to these on-prem nodes actually are again very similar as if you're deploying on cloud. Now let's dive deep into it in the next slide. Here towards your right you can see the on-prem environment, and on the left we have the cloud environment on AWS, right? As you can see, there is this underlying connectivity between the two over site-to-site VPN, but you can also use direct connect if that's what you would like to do. The EKS control plane shown here sits in the EKS service team account, and then the customer VPC obviously will be sitting in your own account, and the connectivity will be established over site-to-site VPN as shown here. Here you can also see we are showing two EKS hybrid nodes, right? These EKS hybrid nodes have been set up using the deployable package that we share with you and the node ADM CLI that we presented to you. Again, through load balancer, as you can see, your generative AI applications talk to LLM gateway, routed through load balancer, all the way up to your on-prem state. So as you can see, this now comes together as an entire architecture supporting many different requirements that you might have of an LLM serving platform. To summarize, we discussed different requirements of an LLM serving platforms and talked about 4 architecture patterns that we gradually iteratively built to support all these 5 requirements. With that, I would hand it over to Jay to talk about the next AI pioneer use case, that is creative content generation.
Thank you, Pranav. All right, so we've heard about the LLM serving platform. Let's talk about the next use case around training and fine-tuning. And this one's very common challenge that everyone working in the creative industry or role might immediately recognize. How do you generate consistent visual at scale? How do you incorporate your content or characters, proprietary characters and objects into the content that you're generating? Now, one of the major requirements for this use case is how do you maintain that consistency, the essence of the character, the details, the traits, and also scaling to the production level. So let's dive deeper. And you can use generic AI model, the image generation model, but they would not capture your proprietary content, and also they would not produce the consistency. So look at the example here. We have this same prompt that I'm using. It's generating an amazing image. It's also following the prompt, but the character here is differing between the images. And this might be fine for one-off projects, but imagine if you're creating children's book or educational content, or if you're generating marketing campaign, where you want to generate hundreds of images and you want the characters or objects to maintain that consistency across multiple scenes. Generic models simply cannot get you. So imagine, what you want in that case is having this consistent experience across a number of images, similar to the images shown here. So let's talk about a real scenario. A few years ago, one of the studios within AWS created a short film called Pichu. It follows a real-life story of a young Peruvian girl, and I think, and they used the cloud-based infrastructure with artists and creators. Let's use that scenario and let's see if we can extend that same content that they generated using this technique of customization. So we know that the generic models cannot get you the consistency. Before we dive deeper into the solutions, let's just take a second to understand the customization, because that's key here. You're all familiar with prompt engineering. It's a low effort, simplest thing that you can do to adjust models output. But obviously you are all familiar with it for last few years. Next is the context engineering. This is where you are providing the additional context to the model by fetching the right context from the data source that you might have indexed into. And these are really powerful techniques, and you should absolutely use them when appropriate. But for our challenge or for our use case of maintaining that consistency across images, prompting and context alone would not get you there. You cannot simply explain the characters in prompts and expect a pixel perfect consistency. So this brings us to the middle area where you are actually customizing or fine-tuning the model. And Bedrock provides a number of those techniques, starting with fine-tuning with parameter efficient fine-tuning or PEFT, where you are adjusting a subset of parameters of the model, so providing an efficient way to fine-tune. It also provides distillation, where you are training the smaller model using a larger smart model while maintaining accuracy. And then you also have this continued pre-training or CPT, where you are exposing the model to additional domain knowledge to expand its knowledge base. And these techniques are require more effort than prompting or context engineering, but they generate tailored output. And then lastly, you have Amazon SageMaker AI-based customization options. Here you can get the maximum flexibility and control, starting with like the full rank fine tuning, where you can adjust all of the parameters of the model. And these are really powerful techniques, but this do require you to have ML expertise. For our use case, we wanted to generate consistent images. So we want to have enough customization power that allows us to have this visual consistent across multiple images. And that's what Bedrock fine tuning provides us. That's what we'll select for our use case. So let's see how Bedrock fine tuning works. So in Bedrock fine tuning, essentially you're providing 3 inputs. You have a base model. In our case, we'll be using Nova Canvas model, which is the image generation model available in Bedrock. Then you provide the input data, right? That's a key thing here, and we'll dive into it. And then the third thing that you provide as an input is hyperparameter. That basically controls how the model training happens. So for data, as I talked about, we are starting with videos, because that's the videos are generated by that studio that we're going to be using. For your use case, if you have the data available in image format, obviously you can ignore that optional block you see here. But in our pipeline, since we are starting with the video, we can sample the video, extract the frames from the video so that we have the images. And from that point on, you can use services such as Amazon Recognition, which is a computer vision AI service, to identify whether, first of all, if there is any human or a face in that image, so that you can use that image. Otherwise, you can discard the image because that's not of no use to you in the fine tuning. Another thing that Amazon Recognition allows you is the face collection features, where you can identify which character is in that image, because that's also key, especially if you are training the model to generate multiple characters or have multiple characters, consistency. This also is a key step here. Outcomes of this stage is the raw images, right, where you have this organized images extracted from this video. The next stage is essentially the pre-processing. This is where you can do a lot of things, like if your images are in the right format that your model supports, right? If they are not in the right image format, you want to convert them at this stage. Also, another thing is this is a stage where you can remove the low quality image or non-compliant images. One of the key things that you can do at this stage also is identify duplicated images or the images which are similar to each other. Because you want to provide the diverse data set to the model while you're fine tuning, because diversity in the data will matter for the model quality. So how you can do that is you can use the embedding models, similar to how you might have been using embedding model for the RAG use cases. You can use the same capability of the embedding model, such as Nova multimodal embedding, to identify semantically similar images and above certain threshold, and you can discard and remove the duplicated images in your data set. Again, like outcomes that you're organizing those data into curated directory, another S3 bucket, or maybe different location in the same bucket. The next stage is where you are generating the image caption, the description, right? So you now have images, you need the description, and you're providing those data to the model training. For the generating the description or the caption, you can also use large language model. Obviously, you can use it with humans, but if you're doing it at scale, it will not scale well. So you can use large language model here, like some of the vision capable model, like Claude Sonnet or Nova Pro. You provide the images along with the prompt to generate a descriptive caption, and this is where your prompt engineering skills will matter. And if depending on the number of images that you are generating the captions for, you can also consider using batch inference for cost optimization, right? You don't necessarily need the real-time inference in this case for the data pipeline. But you also don't want to trust the AI-generated captions. And this is also where you can introduce a human review of those captions. You can essentially use services such as Amazon Augmented AI or A2I to introduce or build this human review pipeline, where your human reviewers will validate the captions which are generated by the models are accurate. One of the requirements of A2I is you have to provide or create a template. The template will dictate how the user interface for that human review would look like. And A2I requires you to provide that template in a liquid HTML format. I personally am not familiar with that format as much, so I fired up my favorite AI assistant, Kiro. It allowed me to generate a custom template for my use case. So I described the Kiro, how I want that human or reviewer interface should look like. I provided some of the sample template that are available in GitHub repo for A2I. And then Kiro was able to generate this custom template for my needs to create this side-by-side visuals so that I can have an image on one side and the description that are generated by AI on the other side. And this is actually the human interface, review interface would look like. As you can see, there are images on one side, captions are on the other side. The human reviewer can mark whether this caption is accurate or not accurate. If it is not accurate, they can go ahead and edit the caption. And this is key for your training data, because you are providing and creating this quality data that will go to your model training process. And outcomes, this is actually the image, this is actually the data format that the Bedrock fine-tuning requires for your input data to be in. So this is what your output, final output should look like that will go in the training process. So we talked about the input data, we talked about the model. Let's talk about another key parameter of training is hyperparameters. So there are 3 hyperparameters that you have to use with Bedrock fine-tuning. The first one is batch size, which essentially means that how many samples the model will seize before it adjusts its parameters, right? Adjusts its understanding. The second is steps, also known as epoch in some of the other model training processes. This basically, the fewer steps means faster training, but potentially you have less learning. More steps means deeper learning, but you're also risking overfitting. And overfitting in ML is essentially the model is really good with the training data that you provide, but it would not perform well with the new or unseen data, and you don't want that. And the last key hyperparameter here is the learning rate, and perhaps it's the most critical parameter. So think of it as like driving. You're driving too slow, you'll not reach your destination, also known as convergence in the ML world. Or if you're driving too fast, or your learning rate is too high, you might crash, end up crashing, and that might cause the model instability, right? So you want to maintain the balance in the learning rate. The table here is showing the default value as well as the range that is supported in Bedrock. Also along with it is some rule of thumb guidance on where you should start in terms of the value for each of those hyperparameters. And the key thing here is you don't necessarily need to remember this. The information here is like Bedrock makes this fine-tuning accessible to you. You're not managing large clusters, you're not writing distributed training code. What you're doing is you're adjusting the parameters based on the amount of training you need for your use case. So let's take a peek into what's happening in the background when you start the fine-tuning job. Your customer training data sits in your account in S3 bucket, and then there's Bedrock owned and operated account essentially temporarily uses that data, accesses through the VPC endpoint, copies it over, and then starts the fine-tuning job along with the hyperparameter that you chose in the earlier step. And then out comes the customized model, and then at that stage you will either deploy the model or you can generate another iteration of it, right, based on the output value. And then you can access this model using the same way that you are accessing any other Bedrock model. Same API, just a different endpoint. So let's say you fine-tune the model. What's next? How do you know that the model is actually better, right, compared to, let's say, a generic model or any other previous iteration of the model? And this is where evaluation comes in. Evaluation typically means that you're providing an output for a set of input to an evaluator. Evaluator could be a programmatic evaluation, it could be human, it could be another large language model. And for our image generation or consistent use cases, there are multiple valid ways to generate image. So it's not easy to compare it to a reference images just like it might be for any other like a text-based generation. So for image generation use cases, comparing the output to a reference is generally difficult, and that's where you want to consider rubric-based scoring. It's very similar to how you might have seen like your teacher grading your essays, or you might have participated as a judge yourself in certain contest and you're given a rubric. Very similarly, the same concept applies here, is you are giving the rubric to the model, to either human or the model, and then they will assess the quality of the output or the images against those rubric elements. And the critical thing here is because you can evaluate number of things. You can evaluate subjective elements using rubrics, whether it's the aesthetic appeal or whether it's the creativity. You can also scale efficiently without requiring the number of reference images for each test cases if you're using the rubric-based scoring. And lastly, you can also gain granular insights into where your model shines and where it fails so that you can adjust it in the next iteration with the rubric-based scoring. And as I mentioned, you can do this rubric-based scoring using humans can be that evaluator, but there are a couple of challenges. One, it wouldn't scale well, especially if you're evaluating hundreds of thousands of images. And the second is human inherently are prone to bias. We like certain image or certain output more than the other, even when you are given the rubric, right? So that's where LLM-based evaluation would be key here, and also often known as LLM as a judge evaluation. So let's see how we can build a sample architecture of a LLM as a judge evaluation for our character consistency use case. On the left-hand side, you see here is the image generation pipeline. Here you have this customized model that we fine-tune, the Nova Canvas model, and then you are generating the set of output images for the input. We are storing those images in S3. You're storing the metadata information in DynamoDB. The metadata could be the key attributes, including the input prompts, because you want to have that input prompt information for the corresponding image, because you will be using that for the evaluation. The next is you have this evaluation orchestration. This is where you can use the event bridge to trigger the event. You can trigger it based on certain schedule, or you can trigger it based on specific events, like let's say end of a training job. And then step function will basically manage the whole workflow orchestration. At the bottom here you see is the evaluation service with Lambda, which is containing the main logic here. It basically fetches the images from the S3 along with the metadata from DynamoDB. It fetches the rubric template and then creates this evaluation prompts, and then sends those images, the metadata, and the prompt to Bedrock for the judgment, and then generates the formatted output. And the rubric itself shown in the box, in the pink box here, again, you can customize that rubric based on your use case and your needs. You can even make it weighted, right? So certain elements might have higher weight than the other. But the key thing here is like you have this rubric that you're providing to the model. For example, this prompt adherence. Are the model generating the output that you're expecting? Visual quality. Are the images technically sound? Are they realistic, right? And then character consistency, which is perhaps the most important our use case. Are the characters, are the visual trait consistent across multiple images? And then, like I said, you can have different elements based on your use case. And then on the right-hand side, you see is the LLM judge system. You can use any vision language model like Claude Sonnet, Nova Pro as a judge from Bedrock. And then you're providing this set of images. And the key thing here is the set of images. See, if we are not evaluating one image at a time, because we want to have this consistency check across number of images, and that you can only do that when you're evaluating a set of images together. Similar to how humans would do it, right? We would reference the images, compare against each other. That's what you do here as well. And then what comes out is the final data, or the results will go into the data store, and that you can use to visualize using QuickSight or some other visualization service. What makes this powerful is we are not getting subjective opinions here. We are getting the actionable feedback, right? We are getting what's inconsistent and where. And then this is also scalable. Whether you are evaluating hundreds of images or thousands of images, you can use the same pipeline to do that. With human, it may not be scalable, but with LLM as a judge evaluation, you can evaluate thousands of images with the same consistency as the first image that you would evaluate, right? And this is the results or the output would look like. There are 3 different scenes, 3 different prompts, all generated using the same customized model that we fine-tuned. And look at the consistency. We have the same facial features, same style, same character essence across different images. There are different emotion, different settings, but unmistakably the same person in all of those images. And this is what a production-ready system would look like. And this is what you cannot get from generic image generation model. So in summary, in our comprehensive workflow, we have combined the automated video processing with intelligent character extraction using Amazon Rekognition. We did fine-tuning with Amazon Bedrock. to create a customized model that maintains the visual fidelity and then dramatically accelerates the storyboarding process. So now I want to invite Safwan to share another pioneer story about how Misraj AI created Arabic vision language model.
Thank you, Jay. Everyone. So let's me first of all introduce Misraj. Misraj, actually, it's AI lab based in Saudi Arabia. We are one of the top pioneers lab existing in our region. We helping our ecosystem to adopt the AI, specializing for Arabic. We are specialized in the small large language model, which is small mediums can help for the agentic AI. Our team is working on the couple months ago for first vision language model, which is actually helping to fill the right to lift the script and also to fill the gap between a different existence. The challenge in Arabic is not helping in the existing model, large language model. So we become to gather a different data to get an understanding how we solve this reasoning and fill the gaps. Our solution, Basir, actually it's working on first of use cases is the OCR. So we came to here to have a different solutions from gathering the data and labeling the data and how to make it a hybrid and then supervised fine-tuning, and finally we got the right fitting Basir. Let's talking about the four main things here: the data set and what's the experiment we have done, as well the training, finally, and we will see in the result. In the data, we worked in two pipelines, or in the main pipeline that hybrid between the real data and the synthetic data. We started with the data itself, the real world data, with more than 300,000 of data, and with the synthetic data we worked in around 200,000, which is augmented data can be fitting for to the real world. And these data, it's an image that having a captions, have a different approaches with it, filling the issues that can be in the realistic world. We work in a different priority here. We taking a crawl data from a different resources, and we take it from the books and magazine and images. We take it shifting from the HTML to the PDF to processing a different approach with a caption and with a different color, with different dark downs and with the breakdowns. The quality filtering as well, it was one of our challenges that we worked on the pipeline. All of these, it's happened, it's giving us to reach to our pipeline we called WSM, the ability to have the right data fitting and preparing for our next challenge with it, the training. So we came, before we go to the training, the experiment we tried. We tried with working on experimenting more than 7 small models, and with these models we worked on in sequentially to shortening the time and getting what is the more benefit for us that can be saving the knowledge and can be very fine-tuned well with our requirement, and as well its vision models. We worked on 3 top things. The first one is what's the more fit with us as selection model, and the second one, what is the right strategy to keeping the knowledge there with the coder, with the decoder as well, and then we goes with what is the highest length we can take within. With this approach, we worked on the several things. We choosing 3 main models. Then we seen what is the more winning with us for the requirement in the fine-tuning, and what is the more best for our decoder and encoder we can work with it, and which one can be helped with us with the long length for the context. In our process for the training, we came to the point that have 3 main things, is in working in all pipeline data set to be in training at the same time, and with the surgical fine-tuning processing that help us to keeping the knowledge itself within in the model, and how we adopt and inject the new knowledge with our new data there. So we choosing a different strategy here from perspective of the training and perspective to being in the parallel, as well in how to configuration and monitoring the result in the same time monitoring. And this is giving us an advanced way to understanding what is the best decoder only fine-tuned and what is the output can be saving for our existing there. The cost optimization also, it helps us a lot to keeping the portion happening in training in the same models. Here we come to the result that we can call it, it's a SOTA, a state of art. We based as a small models that can be vision model competing with the all top in the market in our Arabic language. So we enabling the OCR for the Arabic language competing with all the key achievement here. So today we are available in the Bedrock marketplace as our model, vision language model, and also is existing working together with similar a lot of customers. Now we are working with more than 140 million document to be digitized and achievement in our models. What we also make it here, we make our own benchmark that help all the another models to be contribute and also sharing on this. Thank you so much, and I will ask Bernav to continue the next chapter here.
Thank you, Safwan. I hope you enjoyed listening to the 3 AI Pioneer architecture patterns for 2025. Now we are in December, right? So we start looking forward to the next year, that is 2026. So what exactly we see as an emerging architecture pattern, right, for AI pioneers? And of course, it has to be agentic, right? You can't get away from that. So let's discuss about what we are seeing. Now, what we are presenting to you is what we call as Intelligent Control and Operations Plane, ICOP, right, in short. What does this actually mean, right? Now think about that what is, imagine you have workloads like, for example, LLM serving and model customization that we presented to you, right? What is our current experience to deploy these workloads, right? You can start with UIs, right? You can go to AWS console, click a few buttons, and it will provision the infrastructure for you, and you can start using that. So UI is first approach to do the deployment, but it is obviously limited, right? It is not repeatable. You need to learn the UI. So if a new workload comes in and it will have some option hidden somewhere, you need to go and find that option and all that stuff, right? So it's complex. The next option that we have is APIs, right? APIs give us programmatic access to the infrastructure and applications, so that way it can be automated. But APIs have got its own limitation, right? You cannot, for example, progress much with API until you learn the request and response formats and many other things that come along with the APIs. The story for 2026 is agentic coding assistant, right? You don't need to use UI, don't need to use API, use some agentic coding assistant of your choice, maybe Kiro. Use MCPs with them and start working on it, right? With very limited upfront knowledge, you can start deploying these workloads much easily. But if you have worked with these agentic assistants, I am sure you have faced a lot of frustration as well, right? The problem being they take multiple iterations, multiple engagement to come to a point, right? Because they are general purpose. They are not focused on a particular workload. They are just a broad intelligence capability, which is very generic, which is very beneficial. Yet it is challenging when you want something very specific like LLM serving. You don't want to be wasting time and tokens talking with it over and over again just to come to a point which you hope can be done very quickly. So that is where there is an opportunity to do better. And that's what we are seeing as where ICOP plays a role. Now what exactly it is? So imagine an experience, right, where let's take the LLM serving platform as an example. The user comes and says, I want to deploy an LLM for a customer support agent, right? Very simple requirement. So user is not telling which model to deploy. User is not saying which infrastructure to deploy in. User is just saying, I want to deploy an LLM which will support my customer support agent. Now, think of ICOP as a simple API endpoint, right? It will be an intelligent API endpoint exposed by the provider itself. So for example, imagine if we as AWS start providing you such an endpoint over our SageMaker service or for our Bedrock service, right? So you can come and just talk straight natural language to our APIs directly. There is no agentic assistant in between, right? Straight API endpoint to which you talk in natural language. Now, you come and say, I want this, and then we ask a few clarifying questions to you. Like, okay, you want this LLM, like how many users you expect to be running concurrently? What are the latency characteristics you need? What is the cost that you are ready to accept, right? A few clarifying questions, yet you will not want to overload the user with asking 5,000 questions, right? That is where the knowledge of ICOP comes in, that because it will be specialized on the particular workload. Here, LLM serving, it's not general purpose, very focused on LLM serving. So it will know exactly the questions to ask, but it will also know what are the smart defaults, right, for a particular use case, because it is focused on that particular use case. So it asks those clarifying questions, you understand better, and then pass on a specification to the next module, that is the planning module. Planning module takes it, looks at the specs and go back and proposes a few deployment options to the user, saying, okay, based on your requirements, maybe here is a performance optimized option and here is the cost for it. And then it will say, okay, maybe there is this other more cost effective option, which is maybe you'll have slightly higher latency, but it will be more cost effective. So it's option number 2 also. And then user makes a choice, like, okay, please deploy the highly performant option for me. And then the deployment module goes ahead and does the deployment for the user, right? And finally, after deployment, it shares that infrastructure inventory to the monitoring module, which then starts monitoring it, right? So with these construct of understand, plan, deploy, monitor, as you can see, these are fairly generic construct, right? You can apply to, we are talking about LLM serving, but you can apply for customization, you can apply it to DevOps agents, you can to anything or any workload you might have, you can apply this construct. Now, how do we build this, right? So here we present a high level, schematic of what the architecture might be. As you would have guessed by now, it will be like a multi-agent architecture, and there is one specific agent catering to each of these, stages that we have described here. Now, agents will talk to each other over A2A protocol, and then they will have a number of tools to which they can connect and get the job done. So, for example, the search MCP and AWS MCP to actually do the deployment, etc. Now, one key point to note here, right? Here, if you see the block, we are talking about a customized small language model. We are not saying go to the biggest and baddest model out there, right? Because all we want is to do that one task and do that one task really well. So there will be these customized small models which will be achieving this task. Now, what would be the anatomy of such an agent that we are showing you, right? This is where Amazon Bedrock Agent Core comes into the picture, and it provides you those key constructs like runtime, agent's memory, agent's observability, identity, many other constructs that you might have heard in reInvent over last couple of days as well. Using that, you can build all of these agents today, right? So you might have a workload. Imagine you're a platform engineering team, right? And you offer services to applications within your organization. It might be worthwhile to think about such an endpoint that you might provide to your developers within the organization. With that, let me summarize what did I present here, right? I think the key difference, the first one is this particular endpoint is fully supported by the service provider themselves, right? So it is not like a generic agentic coding model, and that is why it is well tested for that specific use case. So you don't waste a lot of iterations going back and forth because nobody tested it and they have just given it to you. It is purpose-built SLMs, so it will be cheap, fast. You wouldn't worry about token consumption because mostly such services might be offered free of cost as well by the providers, because overall you achieve the workload on top of them. And then you can also think about ICOP being offered as a tool which can be consumed by your agentic coding assistant, right? With that, we complete our session. Thank you so much for your time today. I hope you enjoyed listening to us as much as we enjoyed presenting. Please do not forget to provide the survey as that is super critical for us to improve in the subsequent years. Thanks a lot.